This is practice example 15.3a from the text. We're given the reaction between 2NH3 in the gas phase in equilibrium with nitrogen and hydrogen gases. We're told that Kc is equal to 2.8 times 10 to the minus 9 at this temperature. We're asked to solve for Kp at this temperature. Now, in the previous video, we just determined that the expression for Kp is equal to Kc times RT raised to the change in the number of moles of gas components in the reaction. And so in this particular reaction, we're given Kc, so we can put that in right away. And remember, K values don't have any units. And that's a good thing sometimes, but it can be problematic at this point right here, because some of us wonder what value of R we use here. And the book instructs us to use the value that has, instead of liter atmosphere per mole K, it's liter bar per mole K. And that value in particular, and I'll give you the three values on the exam, is this one. And we just leave the units out like they do in the textbook. And I'm just checking to see what the temperature was in 15.3a. Goodness, 298 Kelvin. So this was going on at 298 Kelvin. So that's the number that I want to put in here. So the temperature must be in Kelvin. And what is delta N? It is the sum of the products, gases, minus the sum of the reactant gases. So it's effectively 1 plus 3 minus 2. Okay, and of course that's 4 minus 2, just squared. And so when we run this through the calculator, we get a value of 1.7 times 10 to the minus 6. So again, just a little note on this value of R. That will be the one whose units are liter bar per mole Kelvin. So we'll just remind you right here, good a place as any, the values of R given on the exam. They will be 8.314 joule per kmol. The other one is 0.08206 liter atmosphere per mole, you can write it this way, Kelvin. And finally, the value that's given here above, 0.08314 liter bar per mole Kelvin. Okay, let's stop it here and do B on a new